just using black. Here it is. All right, so you know how to do U sub, right?
Yeah.
All right. So, as always, do not use the limits until the very end. So 0 to pi over 4. And
wait,
integral.
how about can I see if I can try it and then I can ask the question?
Okay, go for it.
Can I do it on my paper?
Yes, you can. Tan secant squared dx u equals du equals secant squared dx integral u du equals d squared over 2 c equals tangent squared x over 2 evaluated from 0 to pi over 4. Pi over 4 is just 1, 1 squared, 2 is half, minus 1 equals half. All right.
Hello? It was my
Yo, bro, where did I just lie that just sit down the hallway?
What's the derivative?
No, you got like Superman.
Secant tan.
You got a Superman.
Yeah.
Question from the audience: what is the derivative of secant, which is 1 over cosine? Use the quotient rule. So you have cosine times derivative of 1 minus 1 times the derivative of cosine over cosine squared. This is 0. So 0 minus negative sine over cosine times sine. This is positive sine, so you get sine over cosine times 1 over cosine, which is tangent times secant. So secant tan. So you do that. Poorly placed. Wasted my time. This way I'll never have to do this again.
E. I don't know if I'm even on the right track.
Nope. I can do it again if you want. I'll just blaze through it, erase it, and see if you can do it. So, integral of tan secant squared dx u equals tangent du equals secant squared dx. So we have integral u du equals u squared over 2 plus c, which equals tangent squared over 2 evaluated from 0 to 4, 4, which equals 1/2. Okay.
Wait, hold on. So why did you make u or how did you know to make the
Because
u
the derivative of tangent is sitting there.
Because you know that you want to get dx by itself unless the whatever's with the dx is in the function.
Yes. See this whole thing right
Yes.
here is here.
Right. Okay. So does it matter? Okay. Because I know most problems like he's been dividing both sides by like whatever
You mean
to
like
get dx by
move the
itself.
secant over here?
Yeah.
That's disgusting, but yeah.
But it's usually when it's not trigonometric functions. So
But yeah, you could.
you try to make u whatever else is on the inside, or if the du of something else is the same thing as something in the function.
Yeah.
Because I was like, oh, secant must be u because then it'd be u squared. But that doesn't make sense. Yeah, that doesn't
Yeah.
make sense, really.
I mean, there's another way to do this problem, which is secant is 1 over cosine. So,
What would happen if you made secant the u? Would
okay.
it be like a wave if we were to go?
Yeah, let me do what I'm thinking right now, which is the integral of sine over cosine, that's tangent, times 1 over cosine squared, that's secant squared.
Mm-hmm.
So if u equals cosine, du equals negative sine. Correct? Correct. All right. So then we have dx. So this right here, this right here. So we have negative 1 over u to the third, which equals negative u to the negative 3, which equals negative u squared divided by 2, which equals 1 over u squared, which is, u was cosine, so this just equals secant squared. Is that true? Pi over 4 is root 2 over 2 squared. It's going to equal 4. Did I do that right? Cosine third, u equals cosine, sine. I missed a half. Yeah. Okay, so 1 over 2. Flip this. 4 over 2 divided by 2 still equals 1. It should work, but it's not the easiest. But let's try going through the bushes, which happens on a test. You picked the wrong U. So let's say U equals secant, du equals secant tangent dx. So we have the integral of tangent secant squared. Wait. No, this is u now. U divided by secant tangent.
U squared, right?
Why is it u squared? Oh, yes, you're right. U squared. These cancel.
Why did you? Oh, I see.
Yeah. And secant is left. Secant is u. So you're left with the integral of u squared over u du, which equals the integral of u, which is what was there anyway. So you could actually go either way. No.
You said it was wrong.
Well, okay. Let's continue. I didn't say. Okay. So you
Let's
get
look at the video.
u squared over 2, which is secant squared over 2, right? Which is what I got earlier with my other cosine way. This is the hard part. 0. Oh, I forgot the 0. It would be minus half. Yes, it would have worked. Okay, pi over 4. So this is 1 over 2. Bear me in frame. 1 over 2. Easiest way to think about this is 1 over cosine squared pi over 4 minus 1 over cosine squared of 0, which is just 1. Correct?
I've been lost.
Wait, what?
I've been lost because okay. So first of all, I'm still kind of okay. So I asked a while ago, and I was like waiting. When you take du of some like du is something times dx. Like a lot of the problems we've been doing in class, it's like he will usually divide it by something so that the dx is by itself, or I don't know why he leaves some stuff there sometimes. So my question was, when you leave something with a dx, is it because it's in the function you're looking at, the original function you're looking at? Okay, because then like the
I see what you're saying.
the whatever you take away from the dx and you add to the du, he always puts it outside of the integral.
It's a
as
constant.
in it's a constant, as in
It's a
it's
number.
not part of the function.
Yes.
Okay.
So like, let's say u equals, let's say you have this integral and it has some junk with an x dx, and u equals x squared, and you take the derivative, you get 2x dx. You will
You
have
want to
only
divide it
have
by
this.
2 so that because you have an x in the function, but there's no 2.
Yes.
Okay. And the reason you do that is because once you work it out, then here. Okay, let me try to keep. So, was I on the right track, or did I mess up somewhere?
It's looking good so far, but I wouldn't have picked u as secant. But yeah, go for it.
So then. Okay, so this is what my du is. I divide it by secant. Do I divide it by secant? Because there's no secant in the. Oh wait, no, there is.
Okay.
You divide it by tan because there's no.
You don't have to divide by anything. So there's actually 3 ways to do this problem. So the way you're doing it, you're going to have tangent, secant, squared is just secant, right? And so here's your,
Yeah.
there's your d, right? You have that right there.
Wait, but okay, so hypothetically, if I wanted to divide this part by something so that whatever's left here is only stuff you can find in the original problem. It means this original problem, not this one, right? Like the original function, not the derivative of it. I mean, not the integral. The integral of it.
I see. This is not correct right here. Because you have a u here, and you're taking this integral with dx, and there's no u's. Like you need a du it. So you can't have that left behind. Everything must be u.
What do you mean? You have to take the du of it? Oh. This has to be du.
Yeah, and it can't have tangent x because you're doing du.
So what do you do?
Okay. So I do it again, and I suggest we just do all the problems. And then, like, when you're stuck on Wednesday, you can just watch the video. But here we go. Time to tri-wheeled. I could even quad-wheeled. All right, so we have, for me, u is always brown. The derivatives were pink, second derivatives were purple, integrals were orange, but I don't have pink. So, derivatives will be blue. Derivatives will be red, u subs will be blue. So we have the integral of tan yes, because I can just underline. Yeah, tan just tan secant squared dx say U would be? I said U would be blue. U equals. I would pick the easiest one because I know the derivative of tangent is secant squared. So I'm going to do that right now. Tangent, to show how it works.
That looks easier.
Yes. Tangent x du, which I said would be red, equals
Secant squared.
Secant squared x dx. Of course, multiply it up because we just du dx this thing, right?
Yeah.
All right, so this is why this happens. And we just skip that because it's annoying and not technically correct, and we just put it over here. All right. So now we have this right here, and this right here. So now we go integral u du. And that's it. And you know how to do this integral. This integral is, good question, u squared over 2 plus c. Correct?
Wait, U squared.
If it was an x, you would just go. Right?
That's weird. Wait. So the U is tan x. The U is tan x.
Yeah, let's not think about that,
Times
right?
secant squared.
No. The
Yeah, shouldn't we plug the du back where the u was? So it's secant squared x times secant squared x.
girl. U is this
Yes.
because there's an equal sign. So wherever you see this, you put u.
Yeah.
So you look for tangent and you put u. Wherever you see this, since you see that here, you just replace it with du. This is that.
Okay. So, okay. Okay, well, the way we were doing it in class was like, you to get du, and then you just leave u in the function, and then you take the integral of whatever, like everything else, and then you put the du back where the u was. You know what I'm saying?
I see. I think I know what you're saying.
That's why I'm confused, because I think
Yeah.
it's just like, it's
I
probably like a
think-
different like
All right.
step.
So after you integrate this, right? You know how to integrate this.
No, that's what I'm saying. I'm like,
Okay.
we would write it as like, so we would take the du was the, or sorry, the u was tan x. So we would take
Okay.
the
Okay. So what is the integral of this?
is that z?
Yeah.
Z squared over 2.
Yes. What is the integral of this?
X squared over 2.
No. That's a z.
Oh, so then what do you do?
It's just a constant. It's just x plus c.
Okay.
Right? If this is a to b, this would just be x times b minus a. Because there's no z. That's the only thing. So if you see a u and that's a u, bam. All right. So now that we have that, we have our u, and since u equals tangent, this whole thing now equals tangent squared x over 2 plus c.
Okay.
Right? And for practice, this is how I always do it. And then I just rewrite it, tangent squared x 1 over 2 evaluated from wherever it's going.
In this case, it was from 0 to pi over 4.
0 to pi over 4.
And then you plug it in.
Yes, and so this is 1 over 2 times, here's your graph, pi over 4 is right here, and
tan squared of pi over 4, or like any trigonometric function squared of whatever, is it, do you do it like, tan of pi over 4 is 1, right?
1.
So you square that, you square whatever the tan of whatever is?
Yes.
Okay. So if it was like, for example,
Why is it
cosine.
1? Oh, I know why it's 1. Ha 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 ha.
Mhm.
Because this distance is root 2 over 2, and this one is root 2 over 2, and tangent is cosine, sine over cosine,
Mhm.
which is root 2 over 2 divided by root 2 over 2, which is 1. That's why it's 1. I was like, this distance
So-
can't be 1.
For example, if it was like sine squared of x of pi over 4, would it be square root of 2 over 2 squared?
Which is half, yes.
Just checking because I always forget about that.
That's a good question.
Trigonometric function squared.
That's why I always break it into this. Alright, so 1 minus 0 equals half. That's the answer.
equals, yep.
Now, just
See how like it's not that tricky, it's just like the setup is
Yes.
weird.
alright, so let's no more black and red. So if you went the wrong route, which is the wrong route because I said it is, technically it's correct, but if in your mind, you know, you can see this, secant squared is just that. Okay, u equals secant du, oh, I'm gonna need space, equals secant tangent dx. You see, oh, here's my u. Wrong code. Here's my, which one is u? Here's my u. And here is my du. Correct?
Mm-hmm.
Okay, so then you just write your integral with your u and your du. Same thing, except it's more tricky, which is why I'm interested in this problem. So we get the same old, and then instead of tangent, it's now secant, which is disgusting. Secant squared x 1 over 2 plus c. Okay, and then evaluated from how we're doing this, which is 0 to pi over 4. Okay.
So 1/2
Over 2 times.
1 over cosine of pi over 4, which is okay, square root of 2 over 2, which is 2 over square root of 2,
Yes.
times 2 over square root of 2, which is
1/2.
1/2.
Yeah. And so flip it 2, right?
So 2.
So this is 1 over root 2 squared.
Mm-hmm.
This squared is 2. This squared is 4.
So 1/2, but under 1 is 2.
Flip it is 2. And then 1 over cosine squared of 0 is 1.
1 over cosine.
Right?
Wait.
If you have a graph,
That is.
cosine gives you the x coordinate, and the angle is 0. That's 1.
Yes.
Alright, so this is 2 minus 1 times half is half.
2 minus,
That's
wait,
what
2 minus 1. Yes.
That's what was happening to me earlier. I was forgetting the 0. Because I got programmed by using tangent. And tangent of 0, 0. That's why I would use it. But you gotta be careful with those zeros. Alright, so now I don't think there's e to the x in your class. Let's just do it.
Like logs.
No. Alright, so let's just do lots of problems. Yeah. You have a question about one? Well, okay, so let's do 1.
Let's do
Number 1.
number 1.
Yes. Alright, so we have this thing, a root y plus 1. D, it better be a y. Yes, dy. U equals y plus 1. Du. equals dx. Derivative of 1 is 0.
No, du
Du is
should-
dy.
Wait, no. Also, isn't du y squared over 2 times dy?
Oh my! Now, when you take the derivative, you subtract the power.
Oh. So it's just 1.
Yeah,
Which is
just
just
1.
dy. Yes.
Dy. And so now
was
we
thinking
have
integral.
integral
U
1
squared.
half u.
No.
Yes.
U to the u to the 1 half.
Yes. Alright, so u to the 1 half.
Exactly. And
And-
then you take the derivative of that, or
And
the integral of that, which
integrate.
is
So,
2/3 u to the 3 halves.
yes. 2 over 3 y plus 1 to the 3 over 2. Evaluate it from 0 to 3. And I was going to just say, plug it in yourself. But no, since it's a little tricky, 2 over 3 times, put in a 3, that's 4.
4 cubed is
It's 4.
64 divided by.
No, that's not how you think about it. So, this
It's
is the
4.
same thing as 4 to the 2 over 2 times 4 to the 1 over 2 by exponent properties. Right, if you add.
64 divided by.
No. So since you see how you can add these exponents, this is 3 over 2.
I don't like it that way. Or can you just do
Well,
this this way?
it's just 4 times 2, which is 8. It's not divided by.
Wait, can I just do it as like 4? How do I do this? How do I do this calculator?
4 raised to the 1.58.
So 8.
Yeah, because this is just 1, so 4. Okay, 8. And then minus, put in a 0.
So just 0.
No.
No, it's
What?
1.
1.
It's 1. Which is just
So the answer is 14 over 3. Correct? Alright, that was not so bad. Smash another one. No more plugging in limits. But yeah, it's good to know. So I always make a guess and then check it with the calculator. Because if you just trust the calculator,
I usually do the calculator, then I check it.
bad idea.
Because then I'm like,
You want to know what the calculator should say roughly, and then make sure it gets close. All right, so the other one is the same thing, just from -1 to 0. That's easy. All right, this is where we get the juicy stuff.
we could do 2
R root 1 minus r squared
dr.
dr. U equals 1 minus r squared. So what I'm thinking is, whenever I take the derivative, what must be left must be in here. U. Yes. dr. Now get, yeah. So we have our u, and we have our du. So you should probably divide by -2 over there.
What am I doing? The whole thing. So then it's And I take the derivative of, or sorry, the integral
How
of
is
this.
How is this still in here?
You take this out?
Yeah, this
Wait,
stuff.
you take it out of,
This should be du now.
erase this. Okay.
Yeah. Yeah. Then you just integrate.
Integrate or, okay.
Integrate.
So,
But you have to go back to R.
is this number 2?
Yes. Okay, fine. This is for training purposes only. Okay. Always, when you have your U here, put this back in. But you could do it another way. So we're doing this integral from 0 to 1. If you put 1 into the R, U equals 0. If you put 0 to the R, U equals 1. So you got luck. I don't believe in luck, but you got fortunate. Because when you have a negative, you can flip this, and it's still 1.
Yeah.
But that's not correct. This ones was on the R's, so you put the R in. Okay. Yeah. And just evaluate that at home. So this is 1 minus R squared. Where'd the negative go? Yeah. Okay, I'm addicted, so I'm just gonna do it right now. Negative 2 over 3. If you put in a 1, you get 0 minus, put in a 0 is 1. So negatives cancel, 2 over 3. Okay, that's good.
You want to do one more?
I do all of them.
How about we do one more?
Oh, you're tired?
No. Just my mom and my sister are waiting for me.
Are you kidding?
Yeah.
Okay. I
can
shall
do-
do.
This one. 7A.
I shall do number
That's a good one.
4. Just integral of cosine squared sine dx. U will equal cosine
Those actually help. Why'd you take 2?
du
Oh, okay.
equal negative sine dx. So we'll have an integral, non-minus, u squared, du. Integrate this, plug in the cosine back again. And that's that. That's for number 3. I like the lie. It's number 4. Okay. Number 5. No, number 4b. Same thing, just different pounds. Number 5 will be similar to the one I'm about to do, which is number 7. So 7 is the integral of 5r over 4 plus r squared dr. And of course, since this is just a constant, I shall move this out. Ugly. Sorry, no offense. U will be, if I take the derivative of this r, I should get some kind of r-lit. So 4 plus r squared du equals 2r dr. So r dr. So now we have our integral of 5 over 2. And this is that, so the du takes care of that. The 2 is here. So 1 over u squared to u. That is just -2. So when you integrate, you're going to get u to the -1 divided by -1 times 5 over 2. U back in. This is -5 over 2 times 1 over 4 plus r squared plus c, and then plug in the bounds. Alright, it's time to check the answer, which is the final exam, so you better check the answer and take the derivative. So we have -5 over 2 times 4 plus r squared, then -1, and now -1. So we have -5 over 2 times -1 times 4 minus plus r squared and -2, and the derivative on the inside, which is 2r. So this cancels with that. This cancels with that. And we're left with 5r over 4 plus r squared, which is what we have there. So it checks. Okay. And don't forget the exponent there. Alright, that's how you check your answer. On the final, always check if you take the derivative, integrate it, see if it goes back. If you integrate, take the derivative, see if it goes back. Let's grab another one. I wish all my classes were this easy. None of them look difficult now. Maybe 8.
They're all like this, and like similar to that same thing.
8 looks pretty bad. You want to give 8 a try? If they're so similar? No, that's what I thought. Alright, so we have 10. I'm going to pull that out. Times v to the 1 over 2 divided by, where did it go? 1 plus v to the 3 over 2 all squared. I'm assuming dv. Yes, dv. Alright. Notice if you take the derivative of this, you subtract the power by 1, and you'll get that. So we're going to make u equal 1 plus v3 over 2. Du will equal 3 over 2, 2 over 3, 2 over 3 du, v to the 1 over 2, dv. Alright, so now this is the integral. 10 times 2 over 3 times 1 over u squared. Same exact thing as before. It's going to be -1 over u. Okay, fine. Let's talk it out. This is -2. Add a power makes it -1. So we get u to the -1. Divide by the new power, so divide by -1. So we have 20 over 3 plus c. So -20 over 3, 1 over 1 plus v to 3 over 2. And on the final exam, you always check your answer, take the derivative, use the chain rule. Yeah, you're gonna have to use chain rule, and it will go back. Any other ugly ones? Oh, look at number 23. Aren't you an ugly duckling? Sorry, no offense. Wow.
I don't think he would give us that problem.
Why not?
Because the homework only went to 21.
And that's why he would give it to you. Root theta cosine squared. Oh. I hope trigonometries. Theta to the 3 over 2 d theta. We're going to make u equal, just notice, take the derivative, will equal something like that. So, theta 3 over 2 du equals 3 over 2, move that on this side, 2 over 3, theta to the 1 over 2 d theta. So now we have the integral of 2 over 3 cosine squared u and cosine squared u equals 1 over 2 1 plus sine 2u. Okay, so now we have our integral of 3 over, no, 2 over 3 1/2 1 plus sine 2u du. Actually, I could have kept it blue. Which equals the integral of 1 is u. Integral of 1 is u. Integral of this is -1 over 2 cosine 2u. And this is just 1/3. And then plug in your u, and you'll have thetas. All right.
Amazing.
I know, right?
Thank you.
You're welcome.
Now I have all the notes.
Any other questions other than integrals? Like limit questions, derivative questions, chain rules?
No, I got those. I was really confused about this.
Shelling and revolving.
Shelling and revolving, I'm so confused, but what do we do?
Send them home in BART?
Send them. Oh no! Like my mom and sister are like in the car, like
That's what I mean.
and,
Send
like
them
in
home.
their car.
Send them home and you BART.
No, because I have to work early tomorrow,
How early?
7 a.m.
And what time is it now?
Late. It is late.
What time is it?
It is.
What's the time?
It is 8 o'clock. It's almost 8 o'clock.
I think I should go over shelling and
I think-
revolving.
I think I appreciate it, but I
Okay.
will have to figure it out later.
Yeah, that's gonna be hard. You're gonna have to. Does he have office hours?
He does, and so does Elaine. So,
A lot.
Elaine.
Okay.
And the MLC I've been going to.
You should. I don't think they'll explain it.
They're like, I just like tell them what I know, and then they like explain it from there, which is like pretty helpful.